In OZmap, you can access the power calculation for each element from the OLT to the client. In this video, I'll show you how this is possible in each situation. Let's go. The first thing we're going to do here is define the initial power value in the pawn. Then you can go to the side menu under OLT types and change the default power per port in the settings. Just go to this icon here, which will show you the default power per port for each type of OLT, which you can modify whenever you want. But you can also create a new type of OLT with the settings you want. It is from this power, set here at the beginning, that OZmap will automatically calculate the power, taking into account the attenuations set according to each type of element. These attenuations can also be configured. So, after the OLT, we'll come here to the element types to define what their attenuation standard will be, whether it's for switches, fuses, splitters, or connectors. For example, here in the splitter types, you can either modify the attenuation pattern of this type of splitter or create a new type with the desired attenuation. To configure it, just go to the same place, in the type details, and you can change all the splitter's settings, including its attenuation. Or in the same way as in OLT type, you can create a new type of splitter and define all its settings. Well, now back to our network, let's go to the POP. Inside the POP, you can see the configuration you set in the ILT type and in its other elements. And you can see and edit the record of how much power is coming out of each pawn. On my POP, I already had everything set. This OLT came with a standard 4-port slot and a power of 4 dBm. By clicking on this pawn in Properties, you can see the power in dBm, which from this port is actually outputting 4 dBm, as I had set. But over time, I added more ports and changed the power of each port. In the end, it looks like this. And by right-clicking here on another pawn port, under Properties, I can see that I've changed the power coming out of that pawn port at some point. And as you check this on each element, for example, in this box here, you can see the power of each fiber by hovering your mouse over it. For example, this green fiber is showing minus 6.7 dBm. You can see this difference in the fibers when they pass through the splitter, which in this case, for example, came in with 1.7 dBm, and in this green fiber, which followed the splitter, came out with minus 5.2 dBm. Inside the box, you also have the option of clicking on the icon with the meter design. Then click on the desired element. In this case, I'm going to click on the splitter, but you can click on any element you want, even if you have clients connected here. In all cases, this window will open here, where you can see the entire path that the fiber takes, its location from the POP to this CTO, for example, as well as showing its attenuation until it reaches the element that was selected with the meter. So, here we have that it started at the POP, at such and such a pawn, the initial power was 2 dBm at the pawn port it's connected to, and here it's 1.7 dBm, and this is the distance from the POP. This also shows the incoming power and the outgoing power. In the case of this splitter, it has 2 output powers, because it's unbalanced. I'm going to deselect this meter icon here to show you that you can still right-click on the splitter to access the element's properties. Here, in the port settings, you can view the attenuation of the ports and enter the installation power and the current power measured by the technician. In other words, if you want, at the time of installation, you can put in the power that was measured on each of the doors, which will remain fixed, and then, at maintenance times, when you put in this current power, you will be able to compare this projected power, the installation power and the current power measured by the technician, as if it were a history in which you can analyze if there is any decay from when it was installed until now. And the power read will be an internal observation, but it will not be included in the system's automatic calculation. So here you can enter the installation power and the current power, click Save and close this window. For clients, it's the same logic. Let's go. First, just click on the client you want, and here, under Mobile Editing, you'll go to Network Details. Here you can see the projected power, and there is also the Read Power field, where you can enter the power at the time of the field measurement. Here we also have the Power Extract, where we see the same list of elements that we saw inside the box. Just click on Power Extract below, and if there's no power coming in, the field won't be enabled. But in this case, there is power coming in. It shows the same way we saw it in the splitters. The location, the type, the element, the attenuation it has suffered since the beginning, the power it has now, and the distance from the POP to here. Also, like the incoming power and the outgoing power up here,